Hello viewers, heat and temperature question 3. We need to find the mass of a sample of ice, given that it takes 13 kilojoules of energy to heat it from negative 3 degrees Celsius to 22 degrees Celsius. We need to include a heating curve in our answer, and we also need to assume some values which are the same as those that we used in question 2. So let's draw our heating curve. So we've got a graph of time against temperature, and our ice begins at a temperature of negative 3. The first stage is where that's going to warm up to a temperature of 0. And then the second stage is going to be, once it's reached a temperature of 0, it will melt. And as it does so, there will be no change in temperature. So the temperature is constant for that stage. And then once it's all melted and become liquid water, it's going to heat up to... For this question, we're only interested in going as far as 22 degrees. So we're only interested in 3 stages here. So the first stage is going to be where the ice warms up to melting point. So we've got, since there's a change in temperature, we're using Q equals mc delta T. We don't know the mass, that's the point of this question. And C is the specific heat. We're dealing specifically with ice here, so that's 2.1. And the change in temperature is, we're going from negative 3 to melting point, which is 0, so that's just 3 degrees. So if we calculate that, we are going to end up with 6.3 times the mass, and the units are in kilojoules, since everything here is given in terms of kilojoules. Then the second stage is going to be where it melts, which means it's a phase change, and we are therefore using Q equals ml. This is the latent heat of fusion because it's melting as opposed to the latent heat of vaporization, which is for when you've got a phase change from liquid to gas. The mass we don't know, but LF we're given to be 334, so we get 334 times the mass, which is again in kilojoules. And then the third stage is when the liquid water warms up from 0 to 22. That's a change in temperature, so we're using Q equals mc delta T. So we've got M times C for liquid water is 4.2, and delta T, change in temperature, we're going from 0 degrees to 22 degrees, so this will be 22. And if we work out the 4.2 times 22, we get 92.4. And we're given, so that's what the total energy in the process is used. So the total energy is 6.3 M plus 334 M plus 92.4 M, and we're given the total energy in the process is 13 kilojoules. All of this is in units of kilojoules already, so that's nice. So that must be equal to 13. And if we add the 3 like terms on that left hand side, we get 432.7 times the mass is 13, and therefore we just need to divide by 432.7, so we get M is 13 over 432.7, and that gives us 0.030. So therefore the mass of ice there is 0.030 kilograms, or 30 grams. Okay, thanks for watching. Over and out.